All right, team, this is the particle motion model problem. Now, before I get started, I'm going to do a couple of things. First, I'm going to write my name on this. Some people did not write their name on the quiz. I need you guys to do that. Second thing I'm going to do is I'm going to read the question. A particle is moving along the x-axis with a velocity of v of t equals negative t squared plus 2t plus 8. This particle moves on the interval negative 4 to 8, and at t equals 0, the particle is at position x equals 6. That's where the particle starts. After I read the question, I'm going to identify the question type. We're going to call these particle motion problems. I'm also going to remind myself what my goal is here. Remember, if you guys get 4 out of 9 points, that'll get you a 3 on the AP test. If you can get to 5 points, that'll give you a 4. And if you can even get 6 out of 9, that's a 5 on the AP test. I just want to frame this for us because I think a lot of us get caught up in, I can't get every single part of this question correct, when really we only need 4, 5, or 6 points. So I'm going to think about my goal. I'm also going to have Desmos.com open. That's going to help us with this problem. And I'm going to start with question A. Question A, or part A rather, wants to know, is the particle speeding up or slowing down at time equals 2? This is speeding up or slowing down. Now, a lot of students are able to find the velocity. So if v of t is equal to, and I'm just using the problem, negative t squared plus 2t plus 8, then v of 2 is going to be negative 2 squared plus 2 times 2 plus 8. And that will all work out to be positive 8. A lot of students get here and they think, oh, the particle must be speeding up. It has a positive velocity. But speeding up or slowing down involves velocity and acceleration. So, my paper moved. I'm also going to have to find acceleration. So, if v of t is negative t squared plus 2t plus 8, I'm going to take the derivative to find a of t. So you can think of this as v prime of t, which is the same as saying acceleration with respect to time, a of t. Using the power rule, I'm going to get negative 2t plus 2. The derivative of 8 is just 0. That means when I plug in 2 into my acceleration, I get negative 2 times 2 plus 2 deuces wild, and a of 2 is going to be negative 2. Okay. That means, oh, and by the way, if you can just get to this part, you get 1 point for finding velocity and finding acceleration. You're already at a point. Even if you can't do speeding up or slowing down, still find these things. But we need to answer the question. This means that the particle is slowing down. Because velocity and acceleration, I probably didn't spell that right, have opposite signs. When one's positive and the other's negative, that means we're slowing down. If they are both positive, we're speeding up. If they are both negative, we are also speeding up. Opposite sign slowing down, same sign would mean speeding up. And that's the second point on this question. wants to know, when is the particle moving to the right? If we're moving right, that means velocity is positive. I'm going to write velocity is greater than 0. You could also say velocity is positive. The question might ask up or down, east or west. Use your best judgment, but here right means velocity is positive. So to do this one, I'm going to find when velocity is equal to 0 first. So if velocity is equal to, using this equation, I'm going to factor out a negative. So I'm going to do the opposite, negative t squared minus 2t minus 8. Because I'm going to go all the way back to algebra 2 and factor this. V of t is equal to negative, and this will be t minus 4, t plus 2. That means at time equals 4 and time equals negative 2, velocity is 0. So you might remember these charts from earlier in the year. We're going to make one column for time, one column for velocity. I'm going to put my points on here. I'm going to go from left to right. So the first one I'm going to put on here is negative 2, draw a line, and then I'll do positive 4. And all I care about is whether velocity is positive or negative. I think it's easiest to test out 0. So I'll do V of 0. I'm going to use this formula right here. Would be negative 0 minus 4 times 0 plus 2, which would be negative, and then in here we got a negative 4, and then a positive 2. If I multiply this all out, I get a positive 8. So I know that velocity is positive between negative 2 and 4. Now, over here, I would just test a different point. I would do negative 3. And over here, I test something else. I do 5 or 6 or whatever I thought was easiest. You guys can work that out on your own. If you do, you should get negative, positive, negative. The other hint here is this is a downward-facing quadratic, so I know that it's going to look something like this. That's where I'm getting my negative, positive, and negative parts from. All right, and we actually haven't earned any points on this question yet, because this doesn't count as a justification. This is just scratch work. What you would have to say is the particle is moving right on the interval negative 2 to 4. And that's plus 1 for the answer. That's my first point. Next point comes from the justification. And again, this doesn't count as my justification. I actually have to write a sentence. And I would just say, because V of t is positive, or I could write that out in words. I could say V of t is positive. And that would be the second point on this question. So while I get out another piece of scratch paper, we're already at 4 points on this. So if your goal is to get a 3 on the AP test, we might already be there. So when you take the real test, you might be thinking, hey, maybe it's time for me to move on to the next question. All right, let's take a look at part C. Let's look at this guy. Part C. We want to know what is the position of the particle at time equals 4. All right, this is an equation we used last week, but I generally write something like this. Final is equal to the initial plus the change. Okay? So let's start plugging some things in. The final position is going to be equal to the initial position plus the change. Now, if I go back to the problem, I see that the particle at time equals 0, the particle is at position x equals 6. That's the initial position. So here, I'm going to put a 6. And guess what? Just using the initial condition is a point. So if you can do nothing else on this problem, you should just write initial plus change and plug in the 6. Now, the change is a little trickier. Just like when we take the derivative of velocity to get acceleration, we use the position function, or velocity rather, is the derivative of position. But to go from velocity to position, we need to use an integral, antiderivative. So the initial value 6 is going to be plus the integral from 0 to 4, and I'm getting that at time equals 4, of the function. Now you could write velocity, v of t dt, or you could do this as the integral from 0 to 4 of negative t squared plus 2t plus 8 dt. All right. So final is equal to 6 plus the integral of v of t dt. Now when I take this integral, I'm going to do some power rule. I'm going to add the 1, t squared becomes t to the third, add 1, and then divide by the new exponent. So again, add 1 plus 2t squared, add 1 to the exponent, divide by the new exponent. And then the derivative of 8 is 8t. And I'll probably want to clean this up a little bit before I put it into my final equation. So I'll say 6 plus, I'll do some brackets because we've already taken the integral, negative t cubed over 3 plus t squared plus 8t. And we're evaluating this from 0 to 4. So we get 6. Now, we're going to do top minus bottom. We have to plug in the top number and then plug in the bottom number and subtract the 2. So it'll be 6 plus, I draw big brackets to remind myself, it'll be negative 4 to the third over 3 plus 4 squared plus 8 times 4. Okay. And then I close my big brackets to remind myself, this is something else. And I'm going to subtract. Now I'm going to plug in 0. Now this one, you'll probably figure out pretty quickly. You're like, Laughlin, isn't it just all going to be 0? I'm multiplying everything by 0. And so this one's actually fine to leave out, but sometimes it's not 0. Sometimes it's 5 or negative 8 or pi over 2, and you have to account for it. Just like you got a point for doing the initial condition, you get a point, whoops, the second point was right here, just for the integral. You've earned your answer point. This is all correct. This is the answer. If you want to simplify, that's great. I'm going to simplify it in a second. But if you stop here, you get the point. If you keep going and make a mistake, you can lose that point. So just be careful. I'll do it out because I know people will want to know the answer. 6 plus, what would that be? 16. 64. Oh, 64 over 3 plus 16 plus 32. And this will all be 0. So you would get 6 plus 64 over 3. 64. 21 and a third. So you could think about this as 21.333. Got to go to 3 decimal places. Plus 16 plus 32. And that would give you, what, 22? I got to do this in a calculator. It's been too long. This would be 75.333. And that would be the final position. All right, one more to go. One more to go. Oh yeah, 3 parts. Okay, part D. Part D. We're doing fine. All right, part D. We want to find the total distance on the interval 0 less than or equal to t to 5. So we want to find the total distance traveled from 0 to 5. Now, for total distance, we have to add in the backwards distance. Let me give you an example. If I run 2 miles out to the Golden Gate Bridge, and then I run 2 miles back, that's 4 total miles. Okay? On this problem, I'll make like a little sketch. The intercepts looks like something like that. This is 4 right here. So we've got a bunch of forwards motion that we have to account for, but then we have some backwards motion that we also have to account for. And we have to do this plus this. This is one of the times, like normally this is negative area, but since we're doing distance, we have to add this in. So we would do the integral from 0 to 4 of v of t dt. And then we would have to do, to account for this negative area, we have to find that part separately. And we're going to add in the integral from 4 to 5 of v of t dt. Now, Laughlin, didn't you just say this was going to be negative? Wouldn't this be like plus and I would get a negative value here? Well, here's what you have to do. You have to use an absolute value. And in a second, I'll show you how to do this on Desmos, but we should get 30 as our answer.